Okay, guys, in this section, we're talking the 4 operations on radicals. So when I say the 4 operations, what do I mean? Yeah, addition, subtraction, multiplication, and division. The same 4 operations you've been talking about since elementary school. And that's a lot of what introductory and intermediate algebra is about. We create these mathematical objects, and then we want to talk about how do we add these things, subtract, multiply, divide. How do we do the regular operations you're used to on these new mathematical objects we've created, on these algebraic expressions we often call them. That's the goal, to do the 4 operations. So let's get right to it. Example, add or subtract is indicated. And we're going to assume all variables are non-negative. So if you were inventing the addition of radical expressions, let's talk about part A. 8 times the square root of 5 plus 6 times the square root of 5. If you were inventing the addition of radical expressions, how would you want to do it? Yeah, you treat the radical 5 like you would if it were an x, right? 8x plus 6x, you get 14x. Same thing here, except you have to remember root 5 is not a variable. It is a number. If you plug it in your calculator, you'll get, 2 point something, right? So it is a number, not a variable. So if you add these together, you would add them like they're like terms and get 14 radical 5. Instead of radical 5, say apples. You have 8 apples plus 6 apples. How many apples do you have, right? 14. By the way, if you wanted a justification of that, what you could do is think in terms of factoring out the radical 5. I'm going to factor it out on the right-hand side from this expression. What's left on the inside if you factor out, if you undistribute a radical 5, what's left? 8 plus 6. And then you can see why we're allowed to add those together. You get 14 times radical 5. So that's really why it works to add like terms together. It's really the distribution property in disguise, isn't it? Okay, but no work needed, just go right to it. In part B, what would you tell me if I said, hey, take 8 radical 3 plus 5 times the cubed root of 3? What would you tell me? You tell me to get lost. You can't do it. Because they're not like terms, right? Root 3 and cubed root of 3, not the same number at all, right? So it would be like trying to take 8x plus 5y. There's no way you can combine those. They're not like terms. So there's nothing to do here. There's not a whole lot to write. Done. That was an easy example. But the purpose is to make you guys distinguish between what's in radical expressions, what's a like term versus like terms versus non-like terms. In other words, you can't do anything else on this one. Okay, and then you're going to tell me to get lost on this one. We have in part C, 2 times the cubed root of 81 minus 4 times the cubed root of 3. You might be tempted to tell me to get lost, but what should maybe we try doing first? Simplify it. Maybe the cubed root of 81, when you simplify it, maybe the radical part will have a cubed root of 3 in it, right? So that's what we're going to do. So the directions would be, before you tell anybody to get lost, you would want to simplify the radicals first, if possible. It wasn't possible in the last problem. Simplify radicals. In this case, it's only one radical, so I'll put the S in parentheses first. Okay, so let's think about 81. Let's do the little factor tree for it. What 2 numbers do you think of when multiplying to make 81? Me too, 9 and 9. Oh, but both 9s contain 2 factors of 3. So what is 81? Prime factorization. 3 to the 4th. How do we want to break it up into its, we're simplifying the radical like we did yesterday. How do we want to break up 3 to the 4th so that, it's a cubed root, right? We're dealing with cubed roots, so we want to break it up into a factor that's a perfect cube and the non-perfect cube factor. How do we do that? You could write it as 3 to the 3rd times 3. So in other words, I could rewrite 2 times the cubed root of 81 as 2 times the cubed root of 3 cubed times 3. And then this, I'm not doing anything with the 4 cubed root of 3 yet. So what can I pull out of that first radical? So, okay, here's why we did what we did. The radical breaks up over multiplication, and you're not actually going to break it up because that's just a mess, but you can essentially take the cubed root of just 3 cubed. What's that going to be? 3. In other words, you can pull out a factor, it's the operation's multiplication, a factor of 3. So what do you get for that first radical when it's simplified? Out front you have 3 times 2, so what do you have? 6 cubed root 3 minus 4 cubed root 3. That one was there from the beginning. Now, do the radical parts look exactly the same, including the index? Yes. So you can think of them as like terms. What would 6 cubed root of 3 minus 4 cubed root of 3 be? 2 cubed root 3. So it's just like taking 6x minus 4x when the radical parts look exactly the same, including the index. Again, this is a number, it's not a variable. 2 times the cubed root of 3, you could get a decimal approximation for that on your calculator. If you don't know how to do that on your calculator, see me. I want you to know how to do that. Any questions on that? So simplify the radical first, and if you can get like terms, you can combine them. Notice in the first example we did addition. In this example we did subtraction, right? So we've covered 2 of the operations so far.